In this video lecture, we will cover the topic such as interacting data from the NoSQL databases and shaping data concept from unit number 3, that is getting your hands dirty with data. So in the shaping data, you have the various topics like this, that is working with HTML pages, and the subtopics in the working with HTML pages are parsing XML and HTML and using the XPath for data extraction. Then comes working with raw text, and these are its subtopics. Then comes using the bag of words model and beyond, and these are its subtopics. And the last one is working with graph data, and these are the subtopics. So in your syllabus it is given in the comma manner, so it is bit confusing. So the sequence is like this, that is the topic and then the subtopics name. So today we will see the parsing XML and HTML and using the XPath for data extraction. Also, you can see over here that using the network X basics again comes over here second time. We have already seen the network X library basics in the unit number 2. So let's start with the first one, that is interacting with data from NoSQL databases. And then we will see the shaping data. So the NoSQL databases means the not only SQL databases. So it is used in large data storage scenarios in which the relational model can become overly complex. So where this NoSQL database is used, it is used where the storage of data is very large. Just for an example, the social media website. So Facebook is using NoSQL databases for storing the various data. So in Python, if you want to do the interaction with the NoSQL databases, then the process is very similar to the relational databases. That is, the first step is to import the required database engine functionality. Then you have to create a database engine, and then you have to make any required queries using the database engine and the functionality supported by the DBMS. So in the NoSQL databases, you can make use of the MongoDB. So MongoDB is one type of database under the category of the NoSQL databases. So the first thing that we need to do in order to establish a connection is import the Mongo client class. So I am importing the Mongo client class from the library, that is PyMongo. And this is further used to communicate with the database. So over here the client is selected like this. So this is what you have to see, just the introduction of interacting with data from the NoSQL databases. Now let's start with shaping data. So into that we will see that the parsing of the HTML and the XML structure. Now this is what the basic HTML structure is. So HTML is one type of scripting language. And what is the full form of HTML? That is the hypertext markup language. So it is used to design a web page. So this is the basic structure of the HTML. That is, this is the document type. This is the starting of the HTML tag, and this is the ending tag of the HTML. Inside the HTML, we have the head tag. Inside the head tag, we have the title tag. And this is the body part of the HTML. So this is the very basic structure of the HTML. So when you are writing any HTML code, then you have to follow this structure. Now, for parsing of the HTML file, we have to use the Beautiful Soup library. So how to parse the HTML file using the Beautiful Soup library, that we have already seen in the unit number 2. Now let's focus on parsing the XML document. So first of all, we have to understand that what the XML is, and then we will see how to parse the XML document in Python. So what is XML? XML stands for Extensible Markup Language. So it is a markup language much like the HTML. So XML was designed to store and transport the data, and also the XML is self-descriptive. Now, what do you mean by self-descriptive over here? So let's see that. So this is the XML tree. This is the hierarchy of the XML. That is, in HTML, we have seen that these are the tags, that is the HTML tag, head tag, title tag. Similarly, in the XML, we have the different tags, and that tags we will call it as the elements. So the first element in the XML tree is called as the root element. This root element has its child element. So this is the child element of this particular root element. Again, this particular child element has its sub childrens like this. So these are the elements which belongs to this particular element. So these are the again subcategories of this particular tag. So again, in this particular tag, there will be some text which is stored within it. So these two tags are from the same parent. So these two tags are called as the sibling tags. So for this text, the parent is this particular element. For this particular element, the parent is the root element. So for this, the parent is the root element and this is the child element. If we consider these two levels, then this is the parent element and this is the child element. Also, the element contains some attribute. So what is this particular attributes? So let's see that. So this is my one particular XML file. So over here, just like the HTML, we have some tags in the XML. But what is the difference? That in the HTML, you have the inbuilt tags. So the tag's name is fixed, that is the HTML is the tag, head is the tag, title is the tag, which is already defined in the HTML and you have to use that. But in the XML, you can create your own tags. So this my dataset tags is not there, which is present inbuilt in the library. So this is my user defined tag. You can create your own tag with your name. Instead of my dataset, you can write only data, you can write only dataset, you can write only my data, like that. So I have created my own user defined tag, that is my dataset tag. So what is this? This will be my root node. So as we have seen in the HTML structure that this is my root element. So first of all, there will be my root node. So this is my root node, that is the my dataset. You can see the my dataset at last also. So what is that? That is again your root node. But this is your starting root node and this is the end of the root node. So end of the root node is shown by the slash like this. So this is how my root node started and this is how my root node gets end. So between the starting and ending of the root node, you have the various different tags and that tags are called as the elements. So you can see that record is my one of the element. Again, the record start over here, the record ends over here. Again, the record starts over here and record ends at here. So these are the different elements in my root tag. So I have two different tags whose name is record. So what will happen? This will be at my index position 0 and this will be at my index position 1. So using the Python, if I want to access the first record tag, then I will use the index position 0. If I want to access the second record tag, then I will use the index position as 1. Now this particular element, that is the record, again contains the subchildrens, that is the roll number, name and branch. So the roll number has the text within it, that is 1. So roll number starts over here, ends over here. Name element starts over here, ends over here, and it has some text inside the tag. Similar way, I have the same structure over here also at index position 1 also. So what is the difference? The text value changes, which is within the tag. Now this is the text between the tags. Now inside the tag, if you have the attribute like this, so it is written that is record space name equals to first underscore record. So these are some values inside the tag, so I will call it as the attribute. So over here my attribute is name and its value is first underscore record. Over here also my attribute is name and its value is first and its value is second underscore record, like this. So this two tags contains the attribute within it, and this three tags does not have any attribute within it. You can also define the attribute within these three tags also. So after completion of the record, that is the first tag, then and then only the second record starts. Now let's see the Python notebook file, that is how to parse the XML. So we will parse the XML file using the beautiful soup. So let's see our XML file first. So you can create your own XML file by writing such code in Notepad. So into my Notepad, I have created one root tag, that is the my dataset. Inside the my dataset, I have the different elements of the record. How many times it is? This is first, second, third, and fourth. So like this, I have the record element 4 times, and the record elements follows the same structure, that is the roll number, name and branch in every different elements. So what is changing? Over here the roll number is 1, then 2, then 3, and then 4, and accordingly the information related to name and branch is. What you have to do is just save this file and save this particular notepad file with .xml as the extension. Mark my words that when you are creating such files, you have to save this file as a .xml extension. What is the by default extension of the notepad file? That is the .txt. You have to remove the .txt and just store with XML data or whatever name, the file name you want to give, and then write .xml. So this is how you can create your XML file, and just save it in the folder where your Python notebook file is present. Now I want to parse that particular XML file using the Python. So I will use the beautiful soup for it. So I have already installed the beautiful soup library previously in my Anaconda prompt. So I can directly write like this, that is from bs4 import beautiful soup. Now to open the XML file, I am writing, that is open into the bracket the file name with extension, and as a second argument I am passing that I want to open the file in a read mode. So I am writing R, and whatever the file is, that will be stored in my object A. Now I want to read that file, so I am writing a dot read like this. So my file contents will get read and it will be stored in my object called data. So let's run this cell. Now what I am doing over here is, that is I am calling the beautiful soup constructor and I am passing the data. What is the data? It is the position where my contents of the XML are read and it is present in my data. So I'm writing data, and which type of data it is. It is of type XML. It is not HTML. It is not only simple text. It is of type XML. So I'm writing that it is of type XML, that this data is of my type XML. And I am storing into my soup object. So parsing the stored data inside the beautiful soup parser. So this is how we have done the parsing. So it means we are storing the returned object. So this particular constructor will return some object and we are storing it in my object as soup. So this is how we have parsed our XML document. Now from the XML document, that is the soup, I am writing soup.find underscore all, and I am writing record. So what will happen? Whatever the records are there into my XML document, so that will be found. So how many I am writing? Find underscore all record. So this is my record tag. So I am writing find all. It means it will find all the record tags and it will be stored in my object called B, and I am printing the B. So I'm grabbing all the tags which is present over here. So let's run this code, that is the soup, and then I am running this code. So this soup dot find all will return some list, and it is stored in my object called b, and you can see a list is written and it shows all the tags which contains the record. So this is my record tag. So the sub elements of the records will also get extracted. So this is my record starting, record end. Within that, whichever the elements are there, that will be displayed. So these are my all the record tags. Now if I want to grab the first tag, so if I want only the first record tag, then it is at index position 0. So I am writing soup.findAllRecord, and then I am writing the index position 0 that I am storing in my object C, and I am printing the C. So what will happen? You can see that this particular record, that is name equals to first underscore record, get extracted over here. Now I am writing that this is my C tag. C tag contains this particular elements. Now from this particular elements, I want to find the element whose name is name like this. And I am storing it in my object called C underscore name, and I am printing that. So you can see this particular name object has extracted, or you can say you have searched this particular name tag within the C. It got found and it is displaying the output. Similarly over here from the C, that is my C object, I want to find the branch tag, that this particular one, this particular branch tag. So I am writing C dot find branch like this. So what will happen? It will get extracted like this. That is my branch, and that is the ICT like this. Now I want the text. I want this particular text which is present within the tag, which is present between the text, that is starting and closing of the text. So for that you can make use of the get underscore text function. So getting the text inside the tags, you can write like this, that is from C underscore name you want to get the text. So you are writing C underscore name dot get text, and that you are storing it into a value object, and you are printing the value object, and you are getting the answer as ICT like this. So this is how the parsing of the this is how the parsing of the XML document is done. In a similar way, you can also parse the HTML document also using the beautiful soup. Now let's see the next topic, that is using the XPath for data extraction. So XPath specifies the path expression that matches the XML data by navigating down the tree. So XPath is used as an embedded query language. XPath is used to navigate through elements and attributes in XML documents. So you can parse the XML documents by using the LXML file also, and the Objectify class from this particular library. So in this you have to just remember this one, that is the root.xpath, and I am writing record slash roll underscore number. So you do not have to specify any index position over here. So what the problem is, if I want to access the roll number from this particular record, then it will start parsing through the root node. So again I am repeating what the XML will do. It will start with the root node. Inside the root node, it is the record node. Inside the record node, again I have the roll number. So the XPath, what it is doing, it is giving you the path like this. That is, you are getting first of all the root over here. That is XML dot get root. Over here you have read your data, it is present in the XML object, and you are writing XML dot get root. So what will happen in the root object, this particular my data set root will be present. Now inside the my data set, I want record element. Inside the record element, I want to access this particular roll number element. So it is helpful, and it will give you the access easily directly to the roll number element. So in the record, if you want to directly access the branch element, so you can write like this, that is the record slash branch. So where you have to write? You have to write like this, that is the root.xpath record slash roll number and root.xpath record slash branch. So this is how you can make use of the XPath for data extraction. Thank you for watching.